Number of particles. Pause the movie while you complete this table. In the first column we have pictures of one molecule or one formula unit, in some cases one atom. In the second column you must give the formula of that. In the third column we look at the number of atoms of each kind in one molecule or one formula unit. But in the last column, we look at the number of atoms of each kind in one mole of molecules. Here we have one carbon atom. Its symbol is C. Obviously, one carbon atom is one carbon atom. Here we have a pile of many carbon atoms. We are now in the macroscopic range. We can actually see this. One carbon atom is microscopic, actually submicroscopic, because we cannot see it, not even with a powerful microscope. But now with this pile here, we have a measurable amount, measurable on our standard scales, and that is called a mole. We have a mole of carbon atoms. Many of these. And a mole is 6,02 times 10 to the power 23 carbon atoms. So these two values, one mole of carbon atoms and 6,02 times 10 to the power 23 carbon atoms, are equivalent amounts. They refer to the same amount of substance, which is a macroscopic amount of substance. You can see it. It's actually 12 grams of carbon. Here we have a picture of an oxygen molecule, O2. One oxygen molecule consists of two oxygen atoms bonded together. Now here we have a gas cylinder containing many of these oxygen molecules. A whole mole of them, in fact. When we have 1 mole of oxygen molecules, we have 2 moles of O atoms. We have 2 times 6,02 times 10 to the power 23 O atoms. Imagine having a pile of O2 molecules that is a mole big. In other words, 6,02 times 10 to the power 23 O2 molecules. And then you cut each one in half, separating the O atoms. You would then have 2 piles, but in this case, each pile would contain O atoms, not O2 molecules. And how many O atoms would there be? If there were 6,02 times 10 to the power 23 O2 molecules to start with, there would be 2 piles, each with 6,02 times 10 to the power 23 O atoms, after you've split them like that. Here we have a picture of a carbon dioxide molecule, CO2. And if we look at the individual atoms making that up, of course there's 1 carbon atom inside and 2 oxygen atoms. If we now have a macroscopic quantity of carbon dioxide, let's make a whole mole of carbon dioxide molecules. There we fill this gas cylinder with carbon dioxide molecules such that we will have a mole of carbon dioxide molecules. That would be 44 grams of carbon dioxide. Inside there's 1 mole of carbon atoms and 2 moles of oxygen atoms. That's not 1 carbon atom and 2 oxygen atoms, but 1 mole of carbon atoms. In other words, 1 group of 6,02 times 10 to the power 23 carbon atoms. And it's not 2 oxygen atoms, it's 2 moles of oxygen atoms. In other words, 2 groups of 6,02 times 10 to the power 23 oxygen atoms. Here's a lead oxide molecule, PbO is the formula, and each molecule consists of 1 lead atom and 1 oxygen atom. If we have a mole of lead oxide molecules, we have 1 mole of lead atoms and 1 mole of oxygen atoms. In other words, we have 6,02 times 10 to the power 23 lead atoms and the same number of oxygen atoms. Notice that we always have equivalent values here. 1 mole of lead molecules is equivalent to 1 mole of lead atoms, and that's equivalent to 6,02 times 10 to the power 23 lead atoms. And it's also equivalent to 1 mole of oxygen atoms inside that mole of lead oxide molecules, and it's equivalent to 6,02 times 10 to the power 23 oxygen atoms. However, 1 lead atom is not equivalent to 1 mole of lead atoms. That refers to a very different amount. Try answer this page before I continue. Here we have sodium carbonate. Notice the little 2 there refers to 2 sodium atoms for every 1 carbon over there. And then we have 3 O's, 1, 2, 3, sodium carbonate. Sodium carbonate is an ionic substance, so we don't use the term molecule to refer to this here, but rather the term formula unit. 1 sodium carbonate formula unit has 2 sodium atoms and 1 carbon atom and 3 oxygen atoms inside it. Now we have a whole mole of sodium carbonate formula units, and that contains in it 2 moles of sodium atoms, which is 2 groups of 6,02 times 10 to the power 23 sodium atoms. It also contains 1 mole of carbon atoms, so 1 group of 6,02 times 10 to the power 23 carbon atoms, and it contains 3 moles of oxygen atoms, 3 groups of 6,02 times 10 to the power 23 oxygen atoms. All the values in this block are equivalent values. They can be used to make a conversion factor. Any 2 of them, one above the other, can be used as a conversion factor. Similarly, all the values in this block are equivalent to one another, and they can be used in pairs to make conversion factors as well. But don't make the mistake of thinking that things in this block and things in that block are equivalent. No, they are not equivalent to one another. They don't refer to the same amount of substance. Here we only refer to a single sodium carbonate formula unit, whereas here we refer to many billions of these. How many of them? A whole mole of them, 6,02 times 10 to the power 23 of them. That's very different from just one of them. Copper chloride, CuCl2. It's also ionic, so we refer to formula unit. It consists of 1 copper atom and 2 chloride ions, 2 chlorine atoms. 1 mole of copper chloride has 1 mole of copper atoms, which is 6,02 times 10 to the power 23 copper atoms. And 1 mole of copper chloride consists of 2 mole of chlorine atoms, not 2 chlorine atoms, 2 moles of chlorine atoms, which is 2 groups of 6,02 times 10 to the power 23 chlorine atoms. Try this page yourself before I show you the answers. Here we have calcium hydroxide, Ca bracket OH bracket 2. Why the brackets? Because we have 2 hydroxyl groups, and that little 2 there refers to the presence of 2 of the whole group that's in brackets. It's not just 2 H's, it's 2 O's and 2 H's, 2 OH's. One formula unit has 1 calcium atom, 2 oxygen atoms, and 2 hydrogen atoms. A whole mole of formula units has 1 mole, not 1, but 1 mole of calcium atoms, which is 6,02 times 10 to the power 23 calcium atoms. It has 2 mole of oxygen atoms, which is 2 groups of 6,02 times 10 to the power 23 oxygen atoms. And it contains 2 mole of hydrogen atoms, 2 groups of 6,02 times 10 to the power 23. So everything in this block is equivalent to everything else in this block for the formula calcium hydroxide. Not for another context necessarily, but for the formula calcium hydroxide, everything in this block is equivalent to everything else. So you can use pairs of these to make conversion factors. So notice always 1 mole is equivalent to 6,02 times 10 to the power 23. 1 mole calcium atoms, 6,02 times 10 to the power 23 calcium atoms. That's always the truth. But it's not always the case that 1 mole calcium atoms is equivalent to 2 moles of oxygen atoms. That's the case for this formula, calcium hydroxide. But it's not always the case. Similarly, everything in this block is equivalent to everything else in that block for this particular formula, calcium hydroxide. Ammonium nitrate. contains 2 N atoms, there and there, 4 H atoms, 1, 2, 3, 4, making ammonium, the ammonium ion, and 3 O atoms, bonded to the other N, making the nitrate compound ion. Now, if we have a whole mole of these, inside there we have 2 moles of nitrogen atoms, which is 2 groups of 6,02 times 10 to the power 23 nitrogen atoms. And we have 4 moles of hydrogen atoms, which is 4 times 6,02 times 10 to the power 23 hydrogen atoms. And it contains 3 moles of oxygen atoms, 3 multiplied by 6,02 times 10 to the power 23 oxygen atoms. Notice here we're not speaking about oxygen molecules, of course. It's not O2, it's not the gas that exists stably in the atmosphere. It's the individual O atoms, 3 of them for each molecule, or 3 moles of them for each mole of molecules, or rather formula units. CH3COOH, 2 carbon atoms per formula unit, and then we have 3 H's there and another H there. So these 3 H's, they are bonded to one of the carbons over there, making the methyl group. Then the other H is bonded to some O's over there, so I'm going to draw them just now. But first, I'm going to draw the O's. We have 2 O atoms per formula unit. They form a COOH carboxylic group over here, and there's that hydrogen. Now, in a whole mole of this, we have 2 moles of carbon atoms, which is 2 times 6,02 times 10 to the power 23 carbon atoms. And we have 4 moles of hydrogen atoms, 4 times 6,02 times 10 to the power 23 hydrogen atoms. And we have 2 moles of oxygen atoms, 2 groups of this number, Avogadro's number, which refers to the number of particles in 1 mole. Again, everything in this block is equivalent to everything else in this block for this particular compound. And everything in this block is equivalent to everything else for this compound. So we can create conversion factors using pairs of these. Iron sulfate, which has got water of crystallization here. This is the water of crystallization. Each formula unit has 1 iron atom, 1 sulfur atom. There are 4 O's there and another 7 over there. That's 7 H2O after the dot. The 7 refers to H2s and O's. In other words, there's 7 H2O, 7 water of crystallizations there. So that makes 7 O's there plus 4 O's there, which is 11 O atoms. And hydrogen, the 7 you can multiply there with a little number, makes 14 hydrogen atoms. You can go count them as well if you like. 14 hydrogen atoms for every 1 formula unit. If we have a mole of these things, we have 1 mole of iron atoms, or we can write it as 6,02 times 10 to the power 23 iron atoms. We also have a mole of sulfur atoms. We have 11 mole of oxygen atoms. And we have 14 moles of hydrogen atoms. So a single mole of this substance, in other words, if we had 6,02 times 10 to the power 23 of these things, contains in it 14 plus 11, 25, 26, 27, 27 moles of atoms inside 1 mole of the whole formula unit. And to understand this, you can think of taking a mole of these molecules and then cutting them up so that each and every atom is alone, and separating the atoms like that, and then making piles, each pile being a mole big. You would end up with 27 such piles. 1 of them would be an iron atom pile, 1 pile would be of sulfur atoms, 11 such piles would be of oxygen atoms, and 14 such piles of hydrogen atoms. So this highlights the importance of qualifying. When you say a mole, you have to say a mole of what? Because a mole of iron sulfate with water of crystallization is not the same substance as a mole of iron or a mole of hydrogen atoms. Because inside this 1 mole are 14 moles of hydrogen atoms. So you must say a mole of what? What are you counting as one particle inside your mole? So again, these are equivalent values for this particular formula unit, and these are also equivalent to one another. These are not equivalent to one another though, because this refers to only one formula unit and this to a whole mole of formula units.